In section 2, we're going to learn how to multiply powers with the same base. You'll hear me say like bases. So I'll put like bases. When you're multiplying things with exponents and they have the same base, like bases, then you're going to find out that there's something that we can do to make our lives a little bit easier. So we want to simplify this problem, just for example. What is 2 to the third power? Well, 2 to the third power is 8. Times, what is 2 to the second power? 4. So what is 8 times 4? 32. So that's one way that you could do that problem. Another way that you could do that problem is you could write out 2 times 2 times 2. Because 2 to the third is 2 times 2 times 2. Times 2 squared is 2 times 2. So now I have 2 times 2 times 2 times 2 times 2. Which if I wrote that using exponents would be what? 2 to the fifth. And what is 2 to the fifth power? 32. So we get 32 either way. For 3 to the fourth times 3 to the first, I'm going to do the same thing. 3 to the fourth can be written out as 3 times 3 times 3 times 3 times 3 to the first is just 3. So this is actually 3 times itself 5 times, which is 3 to the fifth. And what is 3 to the fifth power? 343? 243? Sure it's not 343? It's 243? Oh, okay. So we can get an answer there still. And finally on this one, x squared times x to the fourth, I can write that out as x squared is x times x. And then times x to the fourth, which is x times x times x times x. Well, now what I have here is just x times itself how many times? 6 times. So that means I can write x to the 6th power. Now that's as far as I can go because I don't know what x is, so I have to leave it as x to the 6th power. On these, because they were numbers, I could go ahead and find out what those answers were going to be. But the point of what we're doing here is not to get these answers, 243 and 32. The point of what we're doing here is to see what happens when you have like bases being multiplied. In each one of these cases, the base here was 2 and 2. The base here was 3 and 3. The base here was x and x. Those were like bases. They're the same. Notice that we had 2 to the third times 2 squared, and we wound up with 2 to the fifth. Here we had 3 to the fourth times 3 to the first, and we wound up with 3 to the fifth. Here we had x squared times x to the fourth, and we wound up with x to the sixth. So from these answers, can we come up with a rule for when we're multiplying like bases? Add the exponents. That's right. When you're multiplying like bases, you can add the exponents. But there's something else I want to add here. What happens to the bases? They stay the same. Notice that it didn't turn into 4 to the fifth. It was still 2 to the fifth. It was still 3 to the fifth. It was still x to the sixth. Okay? The base stays the same. So that's our first rule, our first property that we're learning about when we're multiplying like bases or when we're multiplying involving exponents. You add the exponents when you're multiplying like bases, but you keep the base the same. That's a rule that you have to memorize and get used to working with it. So then they give you this. This is the actual property written out. It says to multiply powers with the same base, add the exponents. That's just what we just discovered on that last page. So the algebra version of that is a, some number or letter, to the m power, some number up there, times the same base to a different power. And all you got to do is just multiply the two like bases by adding the exponents. That's what m plus n right there is telling you. A can't be equal to 0. We've talked about why that's the case. M and N need to be rational numbers. What kind of numbers are rational numbers? The word rational has a word in it that reminds you, what is a ratio? Fraction. So it can be a fraction or it can be integers. If it's a fraction, you just add just like you normally would with fractions. Okay? Common denominator probably. So it's no big deal. For example, if I had 4 to the, I can't really read that. What does that say? 1/3? 4 to the 1/3 times 4 to the 1/3 again? Okay, those are like bases, so we're going to add the exponents. What's 1/3 plus 1/3? 2/3, and that's why we get 4 to the 2/3 as our answer. And then that's it, we're done. Or b to the 7th times b to the -4th. These are like bases, so we're going to add the exponents. What is 7 plus -4? That's 3. So b to the 3rd is the answer in that case. And notice that it wound up being a positive exponent, so we didn't have to worry about where to put it or anything like that. If you simplify first and then place your exponents, you're going to be a lot better shape. All right, so we want to simplify 12 to the 4th times 12 to the 3rd. Are those like bases? Are we multiplying them? Yes, so that means we can do what to the exponents? Add them. So I'm going to write 12 to the what? 7th power. Just out of curiosity, what is 12 to the 7th power?
A really, really big number.
It is a really, what is it though? Just read the digits to me. 35831 808. So that's 35,831,808. It's a pretty big number. But that's what 12 to the 7th power is. Okay, how about the next one? -5 to the -2nd times -5 to the 7th. -5, those are like bases, so the base stays the same. To the 5th power, we added the exponents together, and we get our answer. And we could enter that in our calculator and get a result. -5 to the 5th power. What is that? That? 25. You like that? It works. So there's your answer. All right? That's how you do this. How about the next one? 8 to the 9th. And let's just call it good there. We won't worry about what that number is. We'll just leave 8 to the 9th. Okay. Go ahead and do the next 3. What do we get for that first one? 0.5 to the -11. Is that an acceptable answer? My answers can never have negative exponents in them. So that's not an acceptable answer. I have to go one step farther. How do I get rid of that negative exponent? Put it under 1. So 1 over 0.5 to the now 11th power. And that is your answer. You can't leave a negative exponent in your answer here. So we have to go that route. And then if you needed to, you could type into your calculator 1 divided by 0.5 to the 11th power and figure out what that number is. What about this one? We got 9 to the -3rd times 9 squared times 9 to the 6th. 9 to the 5th? Yeah, because these are all like bases. They're all 9s on the base, and we're multiplying those together. So that means we just need to add all the exponents up. So we have -3 plus 2 plus 6, which gives you a result of 5. So 9 to the 5th is the answer. And how about that last one? Y to the 10th. So whether it's a letter or a number, as long as they're like bases, and you're multiplying them, you add the exponents together and you keep the base the same. Okay, moving on, multiplying powers in algebraic expressions. So you can combine only like bases. If they're not like bases, then you can't combine them. Let me go back. These were all like bases, so we could combine on them. We could take care of that multiplication. But what if I had like x to the third times y squared? Are those like bases? No. So there's nothing I can do here. So I just leave it alone. All right? There's nothing to do there. So let's go back over here. You can combine only like bases. Multiply regular numbers together. Multiply like bases. There should be a little dash here. By adding the exponents. But remember, no negative exponents in your answers either. So we're starting to get into a lot to remember already. It's a lot to keep straight. You got to practice. Just try to remember the properties that we talked about so far. We want to simplify this. I said the numbers multiply. Multiply regular numbers together. So we have a 4 times a 9, which is 36. And then we have a z to the 5th times z to the negative 12th. Those are like bases. So what do I do with my exponents? Add them. And we get z to the what? 5 plus negative 12 is negative 7. Now, can that be my answer? No. So what do I got to do? Because I have more than just this one thing here, I'm going to draw my fraction bar. Yep, the 36 stays on top, and the z to the negative 7th becomes z to the positive 7th in the denominator. So there's your answer. All right, let's see if we can talk through the next one. What are we going to do? Any like bases need to be multiplied. The numbers also need to be multiplied. So what am I going to write first? Two times 9 times 3. 54? Well, 2 times 3 is 6, and then 6 times 9 is 54. That's the easy way to do it. And you get 54. All right, now, do we have like bases? Yes. A times a squared becomes a to the third, because that's an a to the first, actually. A little tricky there. So a times a squared is a to the third. B to the fourth has no like base to multiply with, so it just stays b to the fourth. Do we have any negative exponents to worry about? No, so that's the answer right there. Okay, let's talk about the next one. What do we do? Multiply your numbers together, and that gives me 15. By the way, those are called coefficients. Multiply the coefficients together to get 15. And then what? X to the 4 plus 9 is 13, plus 1 is 14. So x to the 14th is what you get. We don't have any negative exponents there either, so that's your answer. All right, let's talk about the next one. What do we do first? Multiply your coefficients. Good. You're right, it's the numbers, but I want to try to get that word in your head. The numbers in front of the variables are coefficients. So when I multiply these numbers together, what do I get? Good, negative 56. Okay. Now what? C to the third times c to the negative second becomes c to the first. So I'm going to write c, and I don't need to write to the first. D squared has no other like bases to multiply with, so it just stays. There's your answer. Okay, what are we going to write on that one? It is 12 because that's a 1 times 12, so we get 12. J squared times j is, j to the third. And you're right, but I'm going to go ahead and write this down anyway. K to the negative second power. That's a negative exponent, which I can't have, so I'm going to write what? Nice job. Over k squared. As soon as you move it, that exponent becomes positive. How about this last one? Kind of a weird looking one. No numbers at all. That's right. Good job. Just because we don't have numbers here doesn't mean we can't add them together. We just can't add them together like we normally do, so we leave it alone. A plus b plus c is the exponent now, with the same base of x. So you can do 8 through 19. Notice that it is all. Make sure you're checking your odd answers in the back of the book so that you know for sure that you're at least doing the problems right. Be careful on the even ones. Make sure those are right too.